Hello, karibu tena kwenye YouTube channel yangu. This is Philip No explaining. So we have here a problem that we are asked to find the solution to this problem. Check whether the function y is equals to x sin x is monotonic on the interval pi over 2 comma pi. On that interval, and we are given 5 marks. Before I start, ningependa kukumbusha kuwa kama ni mgeni katika channel hii, please make sure umesubscribe alafu umeguza bell notification, ndo pindi tu tutakapokuwa na upload video mpya utakuwa unapata notification. Tutaendelea kusonga pamoja, usiachwe nyuma. Okay, thank you so much kwa kuonyesha upendo wa kusubscribe. So for you to solve this problem or to answer this question, first of all you have to know what does the term monotonicity means, and also to know under what circumstances is a function monotonic or not monotonic. So a function, for example, if we are given a function fx is monotonic increasing on an open interval, you can write before we answer this question. Definition. So we are saying that a function fx is monotonic increasing on an open interval. They say on open interval AB if fx is less than or equal to fy whenever x is less than y, and also function is monotonic decreasing on AB if fx is greater than or equals to fy whenever x is less than y. So test for monotonic functions. Test for monotonic functions. We let I is equals to a b be an open interval, and let f from I to real space R be differentiable then 1 the function f is monotonic, increasing if and only if the first derivative of fx is greater than or equal to 0 for all x in I. Then 2, the function f is monotonic, decreasing if and only if the first derivative of fx is less than or equal to 0 for all x in I. And we have also to note that if a function changes its signs at different points of a given region or interval, the function is not monotonic and in that region. So to prove non-monotonicity of a function, it's enough to prove that the first derivative of fx has different signs at different points. So up that point, you have known or have learned or have reminded ourselves what a monotonic function is, or what do we mean by monotonicity, non-monotonicity, and the test for monotonic functions. So back to our question, check whether the function y is equals to x sin x is monotonic on the interval pi over 2 comma pi. Solution: fx given the question is equal, or not fx but y, in this case is y is equals to x sin x. So the first step is to find the first derivative of y. So here we apply what we call the product rule. In calculus, the product rule. We take our u to be x, then v to be sin x. Remember, the product rule says that u dv, in this case dx, plus v du dx, or can say u, then the derivative of v, u times the derivative of v plus v times derivative of u. That's what we call the product rule. So our u, we have taken it to be x, then our v as sin x. So the derivative of u du dx is equals to 1 out there. Then dv dx, derivative of sin x is cos x. So our y prime, or the first derivative of y, is equals to u x dot derivative dv dx is cos x. Are we there? Then plus v, what's our v, sin x dot du dx, which is equals to 1, and this becomes x cos x plus sin x. Are we there? So the second step, or the next step, is applying x is equals to Now this. Now we plug each of these in the in the first derivative of y. So we start with pi over 2. Pi over 2. Where there is x, we substitute pi over 2. So we have we have pi over 2 cos pi over 2 plus sin pi over 2. Are we there? Thus this gives us cos pi over 2 is 0, so multiply by pi over 2 is 0. Are we there? Plus sin pi over 2. Sin pi over 2 is 1. So the answer is 1. And 1 is greater than 0. The next step, we substitute pi now. We substitute pi where there is x. So applying x is equals to pi. We have pi cos pi plus sin pi. Are we there? And here we have pi, remembering in negative 3.142 rounded off to 3 decimal places. Then cos pi is negative 1, so here becomes pi cos pi becomes negative 3.142 plus sin pi is 0, so plus 0, and this becomes negative 3.1442, which is less than 0. And we can see that the function changes its signs at different points of this given interval. And we have said that if a function changes its signs at different points of a given region or the interval, the function is not monotonic in that region. So we can conclude or say that therefore the function y is equals to x sin x is not monotonic on the interval pi over 2 pi, since it changes its signs at different points of the given interval Hope up that point we are okay, and we are done with that. You have solved. You can see we started with the definition or the explanation of what a monotonic function is, and the manner and monotonicity, and the tests for monotonic functions are here. So this is and we have proved that this function is not monotonic on the given interval because it changes its signs. It changes its signs at different points of given interval. Suppose it was a monotonic increasing then the first derivative could have greater than 0 for all x, or monotonic decreasing if the first derivative of the function is less than or equals to 0 for all x in I. But you can see it's changing the signs, so it's neither monotonic increasing nor monotonic decreasing. So up to that point we have proved, and you have answered the question, you have checked whether the function is monotonic. Thank you so much for watching. Till next time, bye bye.